All right, welcome back to the Security Conversations podcast. A very exciting episode today. I hope. I've spent a lot of time trying to prepare for this episode, and at the end of it, I threw away all my notes, and I'm going to kind of wing it here with Dan. Dan Lorenc is co-founder and CEO of Chainguard, a 1.5-year-old startup tackling software supply chain security. Dan, welcome to the show. Hopefully you'll be able to help me filter out all this noise around supply chain issues and help our audience understand what it all means.
We'll try. Thanks for having me.
Absolutely. Can you, before we get started on supply chain issues, give me a little walkthrough of your background? You have a mechanical engineering background coming out of college. How did you get into this space?
Yeah, I'll go in reverse. So we got this company started just over a year ago. Before that, I was at Google as a software engineer for about 9 years. That's when I got into the cloud, dev infra, open source kind of security area, that whole intersection, which eventually turned into supply chain security. We'll explain that definition in a little bit. Before that, though, I went to school for mechanical engineering. This was physical systems, thermodynamics, engines, heat transfer, all of that fun stuff. I hadn't done any software before college. I didn't do anything, any classes or anything, even in college. We had to learn programming for mechanical engineering, though. We had to learn MATLAB simulations and programming the 3D printers and milling machines and all of that stuff. And I just started to like it more. It was too late to change my major at that point. I was a couple of years in. Figured I'd just finish that one out and look for software engineering jobs after. So that's how I got into this field. It's a lot faster. You're still making things. You don't have to order parts from China. You don't have to wait, weeks for things to arrive before you can build what you're trying to do. It's kind of what got me interested.
Is there an easy transition? Is that an easy transition from the mechanical engineering space into software engineering?
Yes and no. A lot of it was more learning at home, learning on the side. But programming it's gotten even easier to learn on your own at this point. So many resources available online. I started with MATLAB and then picked up Python. Python was big at that point. And then ended up switching over to Go and other programming languages as my career went on.
Google was your first entry into actual security?
At security, yeah. Even toward the end, I'm not a security person. I don't really have a security background. I was doing, mostly infrastructure, software, and developer tooling. Up until 2016, 2017, and then this whole supply chain security area that we'll define that soon started to worry me, and so I started focusing more and more on that before the topic really existed and before it was something that anybody was thinking about.
Well, let's start right there. Why was it worrying you? Supply chain issues are not entirely new. They date back to the 1980s. It's been quite kind of dark through the last couple of years, but there's been documented attacks of supply chain type attacks over the years. Why in the last 2 years you say it kind of really started to worry you?
Yeah, they, like you said, they're not new. They go back all the way back to, the first one I call it 1984, was when Ken Thompson published his famous paper called Reflections on Trusting Trust.
Trusting, yep.
Yeah. Explaining there's some debate now, actually, a couple of weeks ago on Twitter, I saw some debate over whether or not that was a real or hypothetical thing he did, or, whether he just talked about how he could have or whether he actually did it. I think he's confirmed he did it. Twitter. Yeah, I think he said he's done at least parts of it. Some of it was theory, but he did actually, do quite a bit. And then I think, everybody just kind of forgot about it for a while. We're seeing the spike now for a combination of reasons. If I had to guess, there's no clear answer. We could go find a bunch of attackers and go ask them why they're doing it.
Wait. I want to get into the spike and the data in a little bit, because are we really seeing a spike, or is it just a spike of what we know about, and how much of it remains in the dark by design? Supply chain security issues is a dark thing. Mm-hmm. Right? What was that moment at Google that flipped into, wow, this stuff really, really worries me. Like I said, we've had a few supply chain attacks over the years.
Mm-hmm. Yeah, so I think, what caused me to worry, what caused everybody else to worry, probably a little bit different, but around the same time, much earlier, so before this became a huge thing in open source, a bunch of big tech companies, right? I was at Google. Google got hit, but we weren't the only ones. A bunch of big tech companies got hit around the same time, the 2012, kind of 2013 timeframe, by nation state attacks. So these were Different, nation states, advanced threats. You're getting.
Are you referring to
people,
Aurora or post-Aurora, additional attacks post-Aurora? Okay.
yeah, Aurora. When those first got detected, 2012,
That was
2013.
earlier, 2010, 11.
Maybe, yeah. So I joined in 2012, right when stuff was happening. This is the same time as the NSA Snowden papers era too, and it kind of reflected a fundamental shift in how people thought about security at that point. Before then, kind of a lot of this fed into zero trust too, another buzzword that created, but it kind of created the shift from we're all one big company, we're all trusted, everybody has access to all of the infrastructure inside because we all work here and trust each other. To, well, we're a big company at this point. We have 20, 30,000 engineers. Probability would say there's probably a high single-digit number of folks that are working for a nation state or working against our behalf and just manage to get through the interview process. At that scale, you just have to consider that possibility and design your systems differently. Right. So it's not that all the memes you've seen of zero trust. Like once you get inside, you have full access to everything. No, kind of inverting that whole model to individual controls and not giving developers access to the entire world. And locking systems down so that one compromised account or one compromised individual doesn't have access to compromise the entire world.
Right, and then Beyond Corp came out of those Aurora attacks, and then the concept of zero trust expanded throughout industry. At Google, you guys were starting to tinker with addressing software supply chain, OS, open source dependencies, and all of that stuff. Can you talk a little bit about the mindset there when Salsa, Sigstore, and all that stuff started to bubble up?
Yeah, so this is still way earlier, in the zero trust Beyond Corp frame, but didn't stop there, right? It was what else can a single person do? It's not just log into a database and steal data. It's who controls the build system, that pushes the code to talk to that database. Who it puts the code into the repository. Who's reviewing that? Taking that same principle, like what could one person do, and applying it to everything that affects production and how stuff gets to production. The Beyond Corp stuff, zero trust networking side kind of took off faster outside. The internal kind of code and development lifecycle security took a little while longer. The Salsa Sigstore open source stuff came kind of right after seeing all that work happen on some of the internal projects I was working on. I switched teams and started working on Kubernetes and containers and all of that stuff, which got started open source outside of our internal infrastructure.
Right.
And that was stepping back 10 years in security. It was what do you mean everybody's building these things on their laptops and setting up Jenkins under their desks and pushing, giant 100 megabyte binaries that nobody can tell what's inside of them to GitHub and downloading them. And, this is the way you just build things in the cloud, and you're just supposed to pretend these risks don't exist. And so that's what caused me to start worrying about it. Just seeing, the right way to do things, seeing, the systems you have to put in place to protect against certain threats, and then, stepping out to this new open source cloud native world that had just started without any of that stuff yet.
Can you, for the audience, I know we're throwing out a lot of product names and buzzwords, talk a little bit about what Salsa Framework is and Sigstore is, because I think it fits into what I want us to discuss a little bit later on.
Yeah, sure. So these are some pretty new open source frameworks and tools to help secure open source supply chains.
Coming out of Google, right? I mean, Google led the development of this and then released a lot of this stuff.
Yeah. So Salsa is a project called Software Supply Chain Levels for Software Artifacts. There we go. SLSA, Supply Chain Levels for Software Artifacts. It's a pretty simple security framework. It's designed to be incremental. So there's levels 1, 2, 3, or 4. And you can work your way up with that by hardening the way you develop software to get to higher levels. This is based off of another system that was built up inside of Google in those early days. There's been a white paper published on it now called Binary Authorization for Borg. That gets into the technical details about how a lot of it's implemented. But it was very similar. There were still 4 levels internally, and teams had to start increasing the levels they were at, and this kind of ratchet would just crank up each year, and you'd have to do more and more and change the way systems were built. And the granularity there is pretty nice too, because you can focus on certain super sensitive systems first and try to get those to level 4, or raise the baseline for everybody and move them from 0 to 1 and then 1 to 2, and kind of make the right decisions at a very like, you don't need to know the details if you're a CISO with 10,000 developers. You just can know, yeah, this one's important. Let's get that one to 4 first, and let's get half of the other ones to 1, and kind of make prioritization decisions that way. So based on that same principle of making sure only 2 people have to review any change, and then applying that to the entire production lifecycle.
What happened from 2014, 15 that changed why we're seeing so much news and visible activity around supply chain incidents? Did something specific happen? Did we get better at finding them? Did we get better at pinpointing areas of, like, what happened that caused what we're starting to see this data, malicious data rising?
Yeah, I think it was a few factors. One, the obvious one you called out, you're a skeptic, I'm a skeptic. Are more of these actually happening, or are we just detecting them more, or are we just looking out for them more? I think that's definitely true, right? You can publish a typo squatted thing on PyPy now, and somebody will notice and start tweeting about it 10 minutes later. Before, nobody was really watching for these things. Open source has risen dramatically too over that time. The open source adoption, it's always been there. It's always been there in the cloud native space, but I think in the last decade is really when it did penetrate fully into these legacy corporate banking, internal environments where it hadn't quite reached in the previous couple decades.
And why did that present such a big supply chain problem?
Well, it's there now, right? It's ubiquitous. Open source is everywhere. You've probably seen the studies now. It's 90% or 98% of organizations, and it represents 80 to 90% of the code and the off-the-shelf application that they slap together.
Right, but you guys have spent the last decade telling me that open source software has more eyeballs, and by more eyeballs, it's by more secure by default, and so on. Why are these two things suddenly in conflict?
Yeah, they're not quite in conflict, and I think the third factor here is what really caused this shift. The third factor we can quite get to is we've gotten good enough at other security, right? We've gotten a lot, like, nobody's full zero trust, but everybody's partially on the way, and most people have heard of multi-factor authentication and know not to reuse the same password on every website. And we have TLS everywhere, and when you log into your bank, you don't see that red X anymore saying your password is getting sent in clear text, and all of the much easier ways have gotten closed at this point, and attackers are going to the next relatively easiest one. You're
making the argument that infrastructure security has gotten so much better that they have to go supply chain side to do so. And then, but why are there a ransomware epidemic everywhere? And I still can't click on stuff. If I work at pick a company, I have to spend an hour a month like doing these fake phishing tests to train me not to click on stuff. Like, that's the reality of an organization. And you're saying,
sure it's not fake? Are you sure it's not a real phishing thing?
That's exactly the point. We've had a big one
at our company. Everybody's asking for gift cards.
Dan, it's 2022 and we can't click on stuff. I mean, we're on the internet and they're telling us we can't click on stuff. That doesn't make any sense to me.
I don't listen. I click all the links. I click them all anyway.
No, but in all seriousness, you're making the argument that infrastructure security and the mitigations and some of the roadblocks that we've built in and zero trust and all these things have really changed the game.
They're not perfect, but they've changed the game. They've made attackers' life cycles harder. And I think supply chain attacks are a little bit different than old ones too.
Easier?
I don't want to say easier. I think the attack radius, the shape of an attack is a little bit different. You can't pick a single person, set up a spear phishing campaign, take over their SMS or something, get that person's emails. Instead, it's like, more like the poisoning the well style. You create something, get a bunch of people using it. You don't know exactly which ones you're going to hack. You don't know which ones you're going to get their credentials from, but you're going to get some. And so it's harder to be as targeted, but the impact is broader and they're easier to carry out overall, I think. But you can't just pick if somebody puts something inside of a vault, you can't just do a supply chain attack and get right into this super hardened environment. But you can still get a bunch of Bitcoin mining time on VMs when people don't lock stuff down and steal whatever data and AWS keys you can find pretty easily.
Right, but at the same time, there are real incidents that are complicated and sophisticated. SolarWinds Sunburst was not a trivial attack. CodeCov attack was not trivial. I mean, there's been a bunch of Linux kernel compromises and so on. That's not been entirely trivial. So they're different. Like I said, you talk about like low-hanging fruit, malicious maintainers, malicious NPM packages, but then there's the integrity issue. I mean, the SolarWinds thing when when you read a deep dive of the technical sophistication of the exploitation techniques, that was a pretty significant thing. And the question to you is, how many of those you believe is currently kind of just burrowing around out there waiting to be detected? We talked a little bit about detection getting a little better, and we know what to look for. Give me a sense of what percentage of all supply chain attacks currently underway you think we have visibility into? Is it 5%? Is it 50%?
It's hard to say, right? I think, the one you talked about there, the SolarWinds one's a great example, and, it almost conflicts exactly the last thing I said of, these aren't targeted. And, I think that was one where they were patient and very sophisticated, and then they walked their way back up the chain, right?
That's the real one that's scary.
SolarWinds wasn't the target there, right? The target was,
Correct.
Those government installations of software. And so that's what people really stared at. And you watch which vendors were getting software installed there. Might be a couple dozen, and you look through those, and then you start figuring out which out of those you want to target. They're not your target, though. They're a means to an end. They're
right.
They're
but I had never heard
in the way.
I had never heard of SolarWinds before that incident, and I guarantee you, there's like 10 of those companies that we've never heard of that are widely distributed everywhere and may be victims of supply chain attacks as we speak.
Well, and I think that's the big shift in why, jumping ahead, why this is such a hot topic in the industry right now. That 2010 Aurora timeframe we were just talking about, unless you were a hyperscaler cloud infrastructure provider with everyone's data, around the world, you didn't really have to worry about nation states. And, a lot of folks would just throw up their hands and be like, yep, if a massive APT with more resources than I have comes after me, it's a risk of doing business. And I guess we'll deal with that then, but we can't plan our lives around it. And now what these more recent attacks have taught us is that, you might not be the end victim. You might not be the target here, but if you sell software to someone that sells software that is the target, now you're in those crosshairs, and now it's a real threat you do have to account for.
Yeah, raise your hand if you've heard
storing that sensitive data.
Yeah, I had this conversation recently. Raise your hand if you've ever heard of CodeCov.
Yeah.
And the blast radius from that throughout Silicon Valley was scary. I mean, there was entire security programs running around with their hair on fire trying to figure out, we use these guys? Are we exposed? And then Rapid7 and a bunch of other companies came up as victims. But that's unlike the integrity side and the targeted attack, APT, high level adversary. Mm-hmm. Supply chain issues also have like a massive quality problem, code quality problem, Heartbleed, Log4j, Shell Shock. I mean, we can go down the list. These are supply chain issues as well. Yeah. Are we addressing? I'm sorry, my head is all over the place because because it's so. I don't know why you decided to tackle this problem. It just feels like it's one of those
It's like that meme of Charlie from Always Sunny in Philadelphia when he stays up all night. He's got the pins and all the string tacked up on the board and gets all tangled up trying to solve a crime case. Yeah, that's what you feel 100%. Like sometimes trying to untangle this.
The question I'm trying to ask is, are we addressing supply chain security as an industry with government executive order and all this noise, all this activity in a coherent way that addresses all these different variants of supply chain issues, or are we having Chainguard focus on whatever integrity and some other folks focus on this, and we just end up in this hodgepodge of trade? I'm trying to figure out, where are we in 10 years from now? Are we on top of this thing? Are we still kind of like in a ransomware epidemic because now some companies are catching up? Where are we?
S-bombs are going to fix it all. Don't worry.
Well, I want to get to S-bombs as well, because S-bombs is kind of dominating the conversation.
It is,
and that's I don't want to get started there, but do you feel like as an industry as a whole, all participants are really in touch with what the scale of the problem?
I don't think so. I think your point, S-bombs are taking up a lot of the conversation, is true. I think there's a few different problems, and I think that's part of it. You can't lump it all into, supply chain security is a problem. I don't think there's one solution to it all, though. It's a bunch of distinct problems when you break it down, and they're all very different. You did a great job just framing it between SolarWinds, the attack on SolarWinds, and then Heartbleed, Log4j, Shell Shock.
Different things, right? Completely different things.
Very different things. To start out with, I break it down into those two categories. There's the integrity problem, which is, we can't trust the code we're running because we don't know how it was built. All of these intermediate systems in the way can be compromised. We're taking people at their faith, that their laptops aren't compromised, that the distribution servers haven't been compromised. And then in the last year, we've seen pretty much all of those things get compromised. So we have little reason to believe people take them at their word, even if we want to, even if we know the person, right? It's so easy to compromise the integrity of these supply chains.
Okay, let's linger there for a second, if you don't mind.
Yeah.
Just linger on the integrity side of things.
Yeah.
How are we as an industry approaching addressing it? Are we even approaching addressing it?
Yeah, I think, the SALSA framework we started with is really just designed around that one piece, integrity. As you move to higher levels, you get higher integrity assurances. I think the NIST framework, the SSDF, the Secure Software Development Framework, does a great job at this as well. There's a bunch of sections in there that tries to cover a lot more beyond even just supply chain security, but there's a big section in the middle that pretty much overlaps and is in line with SALSA, and we work with the folks at NIST as they wrote this. And so I think as these frameworks roll out, we're going to have to address this integrity problem.
And as they roll out, are you getting a sense that they're being adopted? Do you get a sense that SALSA is becoming widespread? Because when you mention these things, they sound like, okay, these are amazing Google tools that has been internal Google tools for a long time, and they just went open source. And where are some of these? They just became available. Are we realistically starting to address this?
It's a big spectrum, right? You talk to some folks and they're planning next year's roadmap and already have initiatives in place. And I think a lot of these attacks, for better or worse, do a great job of keeping these things fresh in people's minds. And inside a lot of these organizations, there are champions trying to improve a lot of this. And every time a different company gets hacked and there's a headline, that's great fuel for them to get funding and resources to go make improvements. Then there's another camp where the SSDF came out and the OMB and other government agencies are starting to put this into contracts and tell folks to take it seriously. And talked to somebody last week and it said, 180 days from now, the OMB says they're not going to renew our contract. Cool, come back to me on day 179. I've got too much other stuff to do right now. So it's a range, but these government regulations are moving at light speed, honestly, for government regulations. And the executive order was barely a year and a half ago. And step one in that is NIST should go tell people how to write secure software. And that's a 6 to 8 to 9 month process of interviewing industry and collating different conflicting opinions and producing a document. Then the next amount of time is figure out what to do with that. And that's what we're seeing now. You can't just go pass a law saying stop putting bugs in software. It's, you have to start farther upstream, and we're not going to buy software unless it's developed securely. And that's what we're seeing now. So this is happening very, very quickly, I would say, for the type of response we're seeing, but it's going to be years.
It's going to be years and years. But the executive order on the .gov energy really does help, though, right? I mean, it's really, really driving conversations and change. I'm seeing CISOs taking courses on how to decipher what an S-bomb means and how we can it's real.
It's real. It's a boardroom topic in public companies. This is a risk slide. I've seen a bunch of them outlining the risk that companies face from supply chain. So it's a real topic. The federal government involvement and attention, it helps keep attention on it, right? I think that's the big one. It takes a while to get the government to move like this, but once they do, the spotlight's going to stay on this until something actually happens.
Whenever I think about the government and software supply chain, let's get into the S-bomb thing now.
Perfect.
S-bomb takes center stage because they've spent a lot of time trying to, even through the CTIA, it was NTIA prior to getting over to CISA. We had Alan Friedman, trying to evangelize this S-bomb thing. A lot of CISOs was, like I mentioned, getting themselves up to speed on whether they should even be publishing their S-bombs. Help me understand from your vantage point, because I feel like you're deeper into the trenches with a better understanding of this than any of us. Sure. What is S-bomb meant to solve?
Yeah. So that's the second half. The first part of the problem is integrity, right? The supply chains themselves. If you're getting software from a certain vendor, you can't trust that you're going to get it securely. The second half here is the inventory problem. And I think that's where S-bomb starts to fit in. The inventory problem is, who cares what cryptographic signatures you have? You don't even know what software is running. How are you going to start verifying stuff? SALSA doesn't matter when you've got shadow infrastructure running everywhere, and when Log4Shell happens, how do you even go figure out what software to check to see if Log4Shell is inside of? Right, it's just spreadsheets getting emailed back and forth, and a management problem of inventory and assets on that side. And I think SBOM is designed to fix that a couple ways, right? The first one is just take it at face value. Somebody tells you the inventory inside a piece of software. Maybe it's right, maybe it's not. You get some more data than you had before. You can look for log4shell a little bit faster. I think the bigger undercurrent of SBOM, and probably why so many folks are opposed to it and everything, is the transparency piece. You're not just providing folks vulnerability management, you're providing transparency into your software development practices. And that is the bigger reason, in my opinion, for SBOMs, and the reason it makes folks so nervous and takes up so much of the conversation. Showing that one vendor's software is COBOL that runs on mainframes and hasn't been updated since the 1980s, versus another one that's on a modern stack with daily rollouts following all of the best practices. You can start to see this data from SBOMs and the way they're produced, the way they're published, the way they're consumed, and that allows people to make smarter purchasing decisions. But it also puts the spotlight on vendors that aren't following these best practices.
Right.
So it's a cultural shift and a technological one.
And it helps elevate some over others.
Right.
It's like putting labels, cybersecurity labels on things, right? It's where are we with SBOMs? We're talking about this ingredient list and the creation of it. We have some specifications for the delivery of it, Cyclone and some of these specs. But are there machine readable tools available today to absorb these things, and how far are we from there? Mm-hmm. Like the existing attack surface management scanning tools, for instance, do they have the ability to absorb an SBOM, read it, and filter out something usable?
Mm-hmm. It is very early days, I would say. It's moving fast. About 18 months ago, SBOM was taking off. It was in all the regulations. I spent a whole day just trying to find tools, install them, and make SBOMs for things. And
right.
At that point, I think I tried 8, and there's probably some Twitter thread we could dig up. I was live tweeting. I tried about 8 of them, and 6 didn't install. 1 errored when I tried to make one, and the other one gave me an SBOM that was just wrong when you looked at line 1. You didn't have to read farther in.
It's very, very early, but you're still bullish on the value that it brings.
Stuff has improved a lot in that amount of time. I'm still bullish that they will improve the transparency and vulnerability management aspects.
Small part of the arsenal.
Yeah, I think it's an important one, and I think I don't think this is the wrong approach to start with, right? We talked about that crazy tangled ball of yarn and all these different problems intertwined. Starting on vulnerability management, getting folks thinking about asset management, I think is the first. I think that is the right step one. Start figuring out what software you have to protect.
Right.
The SBOMs aren't going to be great right away. I think everybody knows that. We're going to improve them over time. Just get something in the right formats. It's a two-sided ecosystem, right? You need to get folks used to producing them, and you need to get folks used to consuming them before we can make them better.
Is it the right place to start?
I think it depends where you are today. It depends on your security posture and everything, right? Some folks do have good asset inventory, and to them, SBOMs are going to be a sideshow and a distraction, right? Why do I need this other weird XML file? I already know where everything is running. This doesn't help me. But a bunch of folks are not. A lot of folks don't have any idea what they're shipping, and so it's raising the bar for everybody, I guess, and starting to get everybody on an even playing field where we can share the same vocabulary and have a baseline understanding.
Are you running into clients and places where generating SBOMs are helping folks to handle licensing requirements and which software, fix their licensing mess?
Yeah. So that's a lot of the early SBOM adoption that has been out there, and hasn't been a ton.
It's helping with that, right?
Yeah, a lot of the early adoption in this space really came from licensing. There were a lot of licensing scares and wars and battles and billion-dollar lawsuits going on about copyright infringement in open source too. Over the last couple of decades. And so a lot of folks started adopting SBOMs for that reason, to prove license compliance if you ever needed to. This comes up in startups every time you raise funding. You have to go produce a list of all the open source code you use and send it to lawyers so they can do diligence and prove you're not infringing. It happens all the time. A lot of the original SBOM work was done around that. And it's a good start, tracking what software you're using so you can track the licenses. I think some of the shift we're seeing now is that licenses didn't change terribly often. They do change in projects sometimes, but there's a headline we see one every week or so when a startup relicenses something. But it doesn't change every commit, right? And every time somebody makes a single change to source code. So they weren't really optimized for this, where every commit does matter for security, right? A bug gets introduced on a Tuesday and then it gets fixed on the Thursday, and you need to know if you're running the build from Wednesday in the middle when the bug was in there. Licenses change on the order of years, but these bugs come in and out on the order of minutes. So a lot of the shift has been making these formats more finer grained, introducing more information to make them usable for security.
When you're thinking about this integrity and code quality issues around software code passing through these pipelines, are you thinking about supply chain issues all the way down to hardware as well, firmware, hardware, that connection there? Because I feel like if you can't trust a piece of hardware or the firmware it's coming through before it gets to the build system, you can't trust anything at all. And in the supply chain conversation, a lot of that seems to me to be getting lost. Am I right or wrong?
Yeah, I mean, that's the dream, right? I mean, there's been tons and tons of work over the last couple of decades. I mean, if you remember like those early scares about like rootkits and things getting hypervised and not knowing they were in a VM and not being able to trust the hardware you're running on. There's been a ton of work in hardware roots of trust and verifiable boot and all of this. And then
we're still seeing APT activity with firmware implantation.
They're going to try.
And we know that the APT actors are living in that layer. I mean, it's just
they're going to keep trying. Then there's this other world of, PGP signing the packages at the top end, and, nobody's really connected the two. And I think being able to get down to a hardware root of trust for every piece of software is achievable. They've done the hard parts down at the hardware level. We've done a bunch at the top software level, and now you've got to connect them.
So the plumbing is done.
Yeah, you just have to plumb in the middle there, like hook it up. You should be able to grab a random, USB stick off the sidewalk, take the piece of software you find on that, and then verify that down to the exact hardware roots of trust of the machines that was built on. There's no reason we can't do that. We're just not doing that today.
We're running out of time, but I got a couple of small issues I want to touch base with, if you don't mind. We talked about integrity and quality, but we're
just getting started.
If you got time, I got time, my friend.
Let's go.
The malicious maintainer issue is one that you mentioned. You mentioned typo squatting and I believe coin mining. We've seen some examples of that. We've seen example of the protest NPM package thing. Is that something that's defendable? Because I feel like that gets dismissed as like easy to do top level stuff and is largely ignored. Is that fair that it's ignored, one? And how do we address that? Like, how as an industry do we address that part of the problem?
I think that's the hardest one, right? I think that's the elephant in the room, the malicious maintainer issue. And there's a bunch of different flavors to it, right? But I think...
So how does a company like Google deal with that, for example, without going into sensitive details? Like, how do you, like, what's an overarching strategy for handling this if it's such a difficult problem?
Hope, I guess, and hope is not a strategy. I mean, there's a lot of low-hanging fruit.
Oh, it's that bad. No, for real, it's that bad.
Yeah, I mean, typo squatting, there's a bunch of techniques for basic stuff like typo squatting and, certain ways to scan code and look for well-known stuff. But, I think if you were a well-funded nation state, I think you'd be crazy to not have a team of 3 or 5 engineers out there just writing open source libraries that are useful, right? Play the long game. In 6, in 9, and 12 months, we've seen with some of these technologies, how well adopted they can get very quickly. And all you have to do is do that and, add value to people's lives, and the stuff's going to get adopted. And then what? Now you've got code and access to repositories that are used incredibly widely. We haven't, and you were touching on this early, like how many of these are out there that we don't know about yet. We've caught a few early on, we've caught a few in the middle, and then there's been a lot of, that amounted to nothing. They didn't do anything. Are we really
catching though? Because the only time we hear about it is when 2 or 3 vendors use it for marketing and PR purposes, right? I mean, like we're not really catching anything. We have some vendors scanning and looking for very specific things and putting out blog posts, and that's how it's raising our awareness. And I argue that it's happening much more than we're actually catching.
I mean, there was a massive, I'm sure it's happening more than we're catching. It almost has to be. I mean, there's a massive GitHub typo squatting campaign from a month or so ago, and that was a sophisticated attack. They were forging commits to look real under certain accounts, and they looked semantically valid, and it wasn't just copy-paste nonsense. And somebody noticed, on day 3 or something, and they all got taken down, and everybody said, this is a big, a bunch of headlines about nothing. And it was like, well, there was a step 2 and a step 3 in this plan. Nobody did all of that for nothing. I think we just got very lucky on a few of these, and I'm sure there's others where we haven't gotten lucky. I don't think there is a technological solution to that one. I think that's the problem. I think
it's a cultural thing where you can kind of fit guardrails in internally, right?
And some of this comes up with the whole nationalistic geopolitical landscape. Somebody from our team did an amazing op-ed about a lot of this, and folks get queasy when you're using open source written by certain countries, and the developers live there and everything, and you don't want to use this one because it's maintained by people in Russia or something. And 99% of the code you're using, you have no idea where the people live, and so people get upset about the 1% where they do know where it is and don't like the answer, and you're avoiding the hard questions of. Where's the rest of it coming from? And you have no idea.
Hi, you paint a picture of chaos, and it fits right in with my own kind of curmudgeon, everything is screwed thing. But the venture capitalists are here to fix it all.
Oh yeah, perfect.
Right? I mean, there's a funding frenzy in your space. You guys, even your round is abnormally large. A round, you raised 50 plus 5, 55 million so far. You have a bunch of competitors coming, raising some seed rounds in the 25 million, 36, $40 million ranges. What are we supposed to take from all this VC activity in the space? Is it just because of solar winds? Or is it just dry powder throwing at things? Or are real companies emerging to help fix what we just described, this massive problem?
Yeah, I think this is a big multi-year, 5-10 year fix for the industry, right? This isn't a short term, somebody's going to come up with some magic answer, everyone's going to buy it and be secure the next year kind of trend. And so I think that's what folks are gearing up for, right? We're all going to be here for a while. There's a lot of work to do. Our approach is, this is supply chain security, but it's development security, really. It's, we have to change the way software is developed. This isn't something you can just throw a proxy in front of and make secure or bolt something on at the end. Or some fancy scanner will find fewer or more vulnerabilities depending on which one you're looking for that day. It really is a change in the way you write software from start to finish. You have to pay more attention to code, open source dependencies you pull in. You have to update them. You have to pay more attention to your own code, even inside of your own company if you're at a large organization. You have to pay attention to how it's built, right? You have to treat build systems like production systems. I think people are seeing each one of these sentences. There's probably 5 startups, hidden in there, the opportunity for them.
And so I think that's why it's such
perfect. Are you starting one?
Don't encourage them. I have enough of these supply chain startups. Every company is a supply chain startup, and it equally enthuses me because we're starting to see some real innovation around things, and knowing how venture capital works and how money is thrown after ideas, 2 guys with an idea, and this spill off downstream crap that the rest of the industry has to deal with because of that makes me worried. So I'm not sure where we are. Are we really throwing money at a really, really significant problem, or are we heading into what cloud was and mobile was and all these other dead categories?
Did you just call cloud and mobile dead categories?
Mobile security is a dead category.
Sure.
But you know what I mean.
Security. Yeah. Cloud security is doing great, though.
Cloud security. You know what I mean, though, right? There's just so much crazy money. Let me ask you a question this way. Sure. Why do you need a 25 million seed round? Whatever happened to the original days of raising a proper $5 million seed round with a good idea, proving it out, getting your ARR up to a certain point before you can get 20 million Series A and then a 50 million B? Or why are you raising a 50 million A? What is the rationale for this massive round?
The letters are sort of meaningless, I think, is some of it. There's different schools of thought there. Does seed just mean the first round you raise? Does A mean the second, or are these all tied to some other broader targets?
Right. And at the end of the day, none of it really matters what you call it, right?
Yeah. I think you see some folks shifting more lower just because with this funding crunch that we've had, it's really affecting later stage companies, and that crunch is hitting people at the B round and stuff right now. And if you come out of the gate, call your thing an A, and 9 months later you've got to raise a B, and you're going against people that have been around for 4 years trying to raise that same B and struggling, you're not going to look as attractive. So I think some of it's, there's even pre-seed rounds now. Have you heard of those? And pre-seed and accelerators and stuff. So it's folks trying to shift stuff earlier to avoid those hard conversations coming later.
There's a certain, I don't want to call it grind, but there's a certain urgency that comes with a startup that's, looking at money running out 6 months from now. And that urgency drives innovation at pace and at scale. That really is encouraging. Are you worried as an entrepreneur? You've got big investors.
I'm worried about
big
lots.
VCs.
Yeah.
Are you worried about that urgency might be missing? Like you're so well capitalized that you don't need to like close this last deal just to hire this next guy. Like that's real startup life. Are you worried at all, or are you just building your thing?
I mean, there's a bunch of variables in play, right? And I think what a lot of folks realize this year is that the macroeconomic climate is a massive one that you don't get to control.
Right.
If you look at what happened in 2020, 2021, when the markets were great and everybody, was doubling every 3 months just because they were around and the money was everywhere, folks were raising 2 or 3 times a year and only getting 6 months of runway at a time and that kind of thing. And that urgency is great, but is it really there if you know you're going to be able to raise
it's not
in 6
months? I mean, you should be raising enough for like 2 years, but I mean,
not last year. The last couple of years, folks were raising constantly and taking small rounds and doubling every 6 months and stuff. And yeah, there's the amount of runway, but if you know the market's great, if you know you'll be able to get that check when you need it, the urgency's not really there either. And then the rug got pulled out from a lot of folks, unfortunately, when the market collapsed and they were trying to hit some target and delayed raising.
Right.
And so, the way we look at it, there's a crash happening right now. The startup valuations are tanked. It's going to take a while to come back out of. So we raised a massive round right before that, and timed that. So, we don't have to worry how bad it gets somewhat, right? Now we just have to worry how long this lasts. And there's pressure, if this lasts 2 years, if this lasts 3 years, that extra month, makes a big difference at that point.
Fair enough, but everyone has to. Chainguard has kind of set the bar for where your funding round needs to be taken seriously, and that's what's like. I feel like it's driving a lot of things. Let me end on this. How is business? How is Chainguard doing? You guys have products in market now. Talk a little bit. Give me the spiel. How are things going there?
Things are going great. Yeah, I mean, our original plan was. We have a bunch of open source tools because that's where we're starting. We're trying to secure open source. We're trying to get developers to think differently about the way they write.
What is the tool?
Code.
Tell me about the tool.
It's mostly around the SigStore project. So signing and verifying the code that they're using, being able to trace that back. And that adoption's been amazing. Right? It's been introduced in almost all popular open source language package managers over the last year. I don't think I've ever seen anything go that fast.
Kubernetes, I saw, yeah.
NPM, Python, Ruby Gems, Maven Central, you name it. And then start to build products based on top of that. So, the open source stuff started rolling downhill faster than we thought. So we spent more time this year working on products than we had planned. So we have 2 products out right now. We just announced those a couple weeks ago.
What are they?
The first product is Chainguard Enforce. So that is our, if you look at software delivery from left to right, the whole shift left analogy, Chainguard Enforce is as far right as you can go, right? This is the agent running.
As far right?
As far right, yeah. So this is the agent running in production, watching what is there, and alerting you, telling you about risks along the way. So it starts out all the way right and gets to look back at the development lifecycle for how things got there. This you throw into containerized environments, tells you what's in your containers. If we find one we don't know where it came from, we can alert you to that. Kind of starting the chain of trust there in production at the last step. So you can have that choke point. You can have an enforcement point to increase security of the artifacts reaching.
You're adopting an assume breach mentality there?
Yeah, I mean, for everything in production, we want to be able to trace that back to the hardware root of trust, basically that we were talking about of, how it got there. If we can't tell, then that's a flag. If we can tell, then great, if that meets your organizational policy. Mm-hmm. This is kind of like the CISO 10,000-foot overview dashboard of your supply chain posture and risk.
And that's one product, the Chainguard Enforce on the far right.
Yeah, that's the one we just did general availability of a couple weeks ago. The other one, though, is starting all the way left, so jump all the way over to the other side. This is Chainguard Images and our Linux distribution called Wolfie. So to really fix this, to get good SBOMs, to have vulnerability management and asset management under control, you need to change the entire tool chain used to build software. We could go build a brand new one, try to convince folks to use it, or we can just build our own version of the traditional Linux distribution that folks are already using. And so that's what we did. We have our own Linux distribution, the first one designed for container environments and for supply chain security in mind, where every single package in there comes from us. We build it using the SALSA principles. We sign it. We produce the SBOMs. We attest to them being correct. And we do the vulnerability management on that for you as well. So that's how we keep the vulnerability scans at 0 when you run a scan on one of these.
Right.
It's because our team is patching them all day. When
the idea is to use them in tandem?
Yep, you can use them in tandem. Yeah, and by using our images to build your code too, then we can instrument all of the tools in there and produce these SBOMs automatically for you, and get to that productive world where your supply chain is secure by default without you having to do anything about it.
Who's the customer here? Do you already have to have a mature security program with certain things already in place? Like what level what level does your security program in your organization needs to be able to absorb some of these?
Yeah, and Force is really targeted right now at folks in regulated, compliant environments trying to meet the new stuff in the executive order and the new NIST framework quickly.
And that's where you're finding business sweet spots, right? In those financial services and those heavily regulated industries.
Yeah, the folks that are getting hit with this stuff first. For the images, they're just a better container-based image. Anybody doing anything with containers should be using our images. They're lighter weight, they're better, they're more secure. There's no drawback. It's just the best container-based image out there. So it's a kind of bottoms-up developer tool.
And the last question, is there a services model as well here where an organization may not have the level of expertise around some of these issues that you guys can bring in? Yeah,
we do that as well. It is a big shift for a lot of folks, and not having the resources to get something done is a big blocker, and we want to be able to get past that blocker and help out. We do a lot of trainings and assessments too, so we do security assessments and audits of supply chains, and almost like a traditional pen test, but on a supply chain. You can think of that as, and then just sessions to just like we talked to you for explaining how we think about the space. We do that too for CISOs, executives, development teams to talk about. Yeah, you've heard this in the news a million times. People keep yelling at you asking for SBOMs. What does this actually mean, and what should you be prioritizing next year?
You and I having this conversation 2 years from now, is it an entirely different conversation, or are we talking about the same thing? And if we're having it 5 years from now, is the conversation changing a little bit? You talked about this as like a 10-year journey. And it's moving fast. We established it's moving very fast. You and I are having a podcast 2 years from now. How much of this conversation you think is changing?
Yeah, I hope anyway, we're not talking about SBOMs as much anymore because they're just there and folks don't have to think about them, right? I think that's really where they have to get to. Your build tools are just going to spit out an SBOM next to the binary. You're not going to notice it, and it's
so in a couple of years, that's all
going
to be standard embedded by default, right?
Yeah. The malicious maintainers problem isn't going away anytime soon. We're still going to see typo squatting. There's a bunch
code quality issues.
Yeah. I think that's going to take a lot longer. Yeah.
So an old curmudgeon like me will be very happy with what the future holds.
Yeah, you'll have all the SBOMs you need.
Thank you very much, Dan. I appreciate the time. This was awesome.
Sure. Yeah, thank you.